Saxon Algebra 2, Lesson 65. You guys, I have such a sad story to tell you. I mean, it's sad for me. You won't really care. I just taught you Lesson 65, and it was beautiful, and it was glorious, and I told you stories, and everything was amazing, and I got the right answer every time. And I finished, and I said goodbye to you, and then I looked up to click off my camera, and guess what? None of it got recorded. I don't know what happened. But you know what that means? I get to do it all over again. Aren't you happy? Okay. The good news is I've already had the dress rehearsal, so this should be fast. 65. The topic is called Advanced Substitution. In a few more lessons, we're going to be doing an advanced distance problem. Abby and I have been talking about that. We're getting really pumped for it. And when we do that, we're going to be managing 4 equations at the same time. So what we're going to do now is practice managing those equations so that when we get the story, you'll be used to how the math works and we'll just figure out the story. Okay. In these equations, in these problems rather, we get 4 equations to start with, not just 2 like we're used to doing in substitution. The good news is they're cute little equations, and they always follow a certain pattern. So I'm going to show you. I'm going to be super paranoid and check my camera a bunch of times. Okay, still going. The equations in this system that John is teaching us to use, there will always be 4 of them. He will always give them to you in this order, and there's always a pattern. If we call them A, B, C, and D, we know this. Either A and B, one of these will be the base. Okay, we'll use that and plug the other equations into it. C will always, and notice that it's rate times time for the same person, it's rate times time for the same person. That's how these will always work. C will always be comparing the 2 rates. One of the rates will be by itself, and that is very important. We're going to come back to that fact. D, the 4th equation, will always relate the 2 times, and it will involve addition or subtraction. Okay, they can be formatted in different ways. This one's usually formatted exactly like this. All 3 of these tend to be exactly like this. This one sometimes takes some different shapes, and we can rearrange it. That's no big deal. The trickiest part of this equation, well, it's not really that tricky. What we do is we look at here to determine which base we want to use. We want to look here. I circled the variable that's by itself, not the one that's being multiplied by something, the one that's by itself. We want the base equation that has that same term in it. So we want to use B for the base. Okay, so I usually put an asterisk by the one that I'm choosing. So what we're going to do is we're going to put that there, and I'm going to put some nice parentheses. It's RB times TB equals 6. Now, RB is all set. It's right there. 3 times RW. Okay? And then TB, well, that one's all set too, isn't it? That looks really good. 2 minus TW. Now, I want you to notice 2 things at this point. Number 1, we've used B, C, and D, but we haven't used A yet. That's good to keep in mind. The second thing I want you to notice right now is that this looks a hot mess. And there is a mild panic that often sets in when students get here because it's like, I don't understand what I'm doing. I don't understand what I'm solving for. I don't know what I'm doing. And I'm here to tell you Don't worry about it. It's going to turn out. Trust me. We want to distribute. It looks weird. Trust me, it's going to be fine. Look what happens. We get 6RW minus 3RWTW. And a lot of students want to cry at this point and go, I just made a giant mess. But look what happens. And this will work out every time. P.S. We created this new double variable term that matches exactly to what's in our equation A that was the one we still needed to use, right? We used the other three. We haven't used A. So what we get to do, it works like a magic every time. It's so satisfying. What we do now is we plug in this value for RWTW, and now we just have one cute little variable and we can solve. This is 18, so I'm going to add 18 to both sides. 6RW equals 24. And so I like to write my answers over here. RW equals 4. Fabulous. So good, right? Now we have to go through and we have to find the other three variables. So I like to do the two rates first. What's our other letter? RB. And C will help us with that, right? We take the first one and we multiply it by 3, so this must be 12. Now let's find the first time. Let's go to this equation, right? So if RW is 4, TW is the one we're trying to find out, it equals 6. Oh, I'm sorry. This should be a 4. We divide both sides by 4, and we find out TW equals 3/2. I reduced it. And now we can go back to this one and get the last time. The other time will be equal to 2, which I'm going to rewrite as 4/2, minus TW, which is 3/2. Hi, Grace. Come here, child. I think it was in the video that didn't last. Grace and I are sitting in that front room by my front door, and the door was shut, and we were happily working away. Sorry, I'm interrupting my math problem to tell you a story. Let me finish this. 4/2 is 2 minus TW, which is 3/2, equals 1/2. So there's our final solution. My daughters are in the kitchen baking cookies, and at a certain point, both Gracie and I suddenly realized that we could smell the cookies in the oven, and she jumped up and left me. How could she? Okay, this problem is exactly the same, and you'll see that the pattern holds. We're going to go through it again. The numbers get a little bigger, but it's not harder. Here come our 4 equations. Notice how the pattern stays the same. The last one looks a little different, but we'll sort that out when we get to it. Okay, so rate times time, matching letter. Rate times time, matching letter. One of these two is going to be our base. The third one, the one that relates the rates, is the one that's going to tell us which one to choose. We look at the variable that's by itself. We want the base equation that has the same guy in there because we want to plug him in. Whoop. That will work beautifully. Now, we're also going to want to plug him in, and I can see this is going to need a little bit of straightening, isn't it? That's fine. We'll subtract TC from both sides, and we'll get TP equals 12 minus TC. Okay, now we're good to go. We'll use this as our base, and we'll say RP times TP equals 693. Okay, RP is equal to 3RC. And TP, 12 minus TC. This is where we get that horrible feeling that we've made a disaster, but we just have faith and we distribute. We don't know what we're doing. We're not being strategic about trying to create these. We're just throwing in what we know and hoping it all works out, and it does. So I'll just spoiler you right there. 36RC minus 3RCTC equals 693. Okay? All right. Cool. Here is the monster we created, And there is the very same variable just waiting to be used. We've already used these three. This one was sitting here waiting for us. So now we get to plug it in. 36RC minus 3 times 165 equals 693. Huh. Okay. That's cool. Again, we didn't set this all up planning that this would be the first variable we would solve for. We just plugged in and algebra'd and waited to see what would happen. So don't feel like you need to have a grand strategy for how this is all going to turn out. We don't know. We just put everything together and see what happens. All right. 3 times 165. I just multiplied a hot minute ago, and I'll tell you right now it's 495. We're subtracting it, so we need to add 495 to both sides. And we get 36RC equals, that all cancels, 1188. Divide by 36, which I just did a minute ago, and I can tell you that RC equals 33. RP, I always do the second rate next. If I multiply that one by 3, it means 99. And then I go back to the first thing and I get his matching time. I know that together they have to equal 165, so 33 times TC equals 165. Divide by 33, and that equals 5. All right, 165 over 33. Try it. If you don't believe me, I just did it a minute ago. And then TP, we can go to this one. TP equals 12 minus 5, so TP equals 7. And let me just double check. 33, 99, 5, and 7. Yay! It worked the second time too. Okay, fabulous. Remember that these 4 equations always follow a pattern. The third one tells you which of the first 2 to use as the base. And then it's a matter of plugging in and just letting it happen and waiting for this beautiful miracle to be created. That's the equation you haven't used yet. And then you just do algebra. All right, I'm praying that this is still recording. Looks good. Okay, I'm going to quit before anything goes wrong, and I'll see you for lesson 66.